Hello, hello. I'm Emily, and welcome to this pigeonhole problem. Let's see what's happening. There are 51 houses on a street. Each house has an address, which is a number assigned to the house between 1,000 and 1,099 inclusive. Show that at least two houses have addresses that are consecutive integers. Okay. The first thing I want to talk about is how do we even know or can guess this is a pigeonhole problem outside of that we just told you, right? Pretend we saw this problem in the wild. What would hint us that way? Well, it says this show that at least two houses. This at least some number feels very pigeonhole. We can't show two specific houses, but we can just show there must exist. We can guarantee you there's two that have consecutive integers. I just have no idea which ones. That idea, this guarantee of a number, but not specifics, very pigeonhole. And once we figure out a problem that's pigeonhole, we have to determine the pigeons and determine the boxes or the holes the pigeons go in, which is often quite a challenge. Some problems are really weird. It's always different. It's something, you hear this a lot, I'm sorry, but you gotta practice them. There's a bunch of problems in, I think, section 6.2 of the textbook, and you just gotta do it. And often the goal with the boxes is, right, we're gonna have a certain number of boxes and we're gonna assign the pigeons, we're gonna name the boxes in a way that pigeons get assigned to them. Each pigeon we have needs to go in exactly one box. Like if we see a pigeon, we need to know exactly which box to put it in. And the goal is that once the box gets filled up, in this case, the filled up is probably going to be two elements in it because we're looking for at least two houses. But if we wanted at least three, the box would get filled up with three elements. But if the box gets filled up, then we need to have accomplished our goal, shown what we need to show, which is that two houses have addresses that are consecutive integers. So our pigeons are probably going to be the houses. They each have an address, and we care about showing something related to that address. So we're probably going to want to make our boxes related to the address. And if the address were like house 57 goes in here, and house 57 isn't even in this numbers, 1057 goes in here, and 1081 goes in this box, filling up this box tells us nothing. Not helpful in accomplishing what we want to show. So a wild guess, we want consecutive integers in these boxes. Like, I'm going to say this is the box where house 1000 goes, and this is the box where house 1001 goes. This is the box for 1002, and this is the box for 1003, and so on and so forth, all the way to our last ones, 1098, 1099. Now every house goes in exactly one box, and if one of these boxes has two elements in it, then we definitely have consecutive integer house addresses. Check mark, check mark. Now you might be wondering, what about, maybe we could have houses with address 1001, 1002. That would be consecutive integers. And you're right. It's just we don't have a box that takes 1001 and 1002 because we already have a spot for 1001 address. We don't want a house to go in two spots. That's not going to work for pigeonhole. And if this top row of boxes can show that at least two houses have addresses with consecutive integers, then we don't even need to consider the 1001, 1002. Like, okay, cool, so what? We did it with just these. Don't need it. And to figure out if these boxes will work, we need to know how many we have. Like if there are 55 boxes in this list, then with 51 houses on a street, that's not going to work. Right? Every house could have its own box. We're not guaranteed to have two. But if we have, 45 boxes, then yeah, definitely we're going to have to repeat some boxes. So let's see. I'm going to simplify these numbers a little bit and just think about 0 to 99. I just subtracted 1,000 from both sides. And how many numbers are in this list? Well, we include 0 and we include 99. So there are actually 100 elements here. This is like 0 indexing an array in C++ if you've worked with that. So we have 100 elements, or 100 numbers, and we group them by 2. And if we divide 100 by 2, we get 50. So there are 50 boxes here. If you're not entirely convinced by that, sometimes I do pigeonhole problems where I figure out the boxes and then it's just hard to count how many there are, and I think I'm right, but I'm not entirely sure. Sometimes I simplify the problem and just see if it would work. What if our boxes were actually numbered 0 through 9? Okay, I have enough fingers for that. There are definitely 10 boxes we could count. And then if we put them in groups of 2, I'm just gonna like stick my fingers together in groups. There are definitely 5 groups. Okay, so 10 elements gave us 5 groups. It sounds good, 100 gives us 50 groups. Okay, another argument about that is 50 a low enough number of boxes that 51 houses will work with pigeonhole. And yes, we will definitely have to repeat at least one box. There's got to be somewhere where there's a box with 2 houses in it. And there might be multiple boxes. That's fine. But there's at least one box with 2 houses in it, which means we at least have 2 houses with addresses that are consecutive integers. And that's all we wanted to know. Notice this note about the addresses don't have to be in order is because we didn't put these boxes in order. We were just like stick 1002 and 1003 in this box. So didn't really pay attention. I guess normally streets, at least in the US, are like the numbers go in order. But that was just kind of a note. The real world doesn't always quite work. My last comment is these are examples of how you could write the solution. Sometimes people kind of struggle, like, what do I say for this? This first one is a solution that 203 instructors wrote a couple semesters ago. It's pretty mathy. Partition the set of integers. The sets contain distinct numbers. You can say the same things, but less mathy words. So you can say something about these are the holes. These are the pigeons. By the pigeonhole principle, we must have 2 numbers in 1 hole, so 2 houses have the same address. Those are all the important parts of the solution. The second solution is from the textbook, Rosen. I also don't like it because they just tell you the pigeons and then they say there are clearly 50 sets. Okay, why are there clearly 50? I don't think there are clearly 50. There just are, but we had to figure that out. And I'm still not entirely convinced. But this is another way to see by the pigeonhole principle, 51 numbers in this range, at least 2 of them must come from the same set. Anyway, I'll stop underlining. Feel free to read through these. Feel free to read through some solutions in the discussion for how to write these. And that's it. Done.